I'm Tom Wood with Aztec, and I have the honor of introducing two speakers and two interesting topics. First one is Matt Johnson with the Upper Great Plains, and he's going to be talking about high friction surfaces and an experience at Mountrail County. And then we're going to be followed by Josh Loegering, who is with LaMoure County, and he's going to talk about OTTA Seal. And of course, I have an old joke about that. But with that, let's give the two speakers a warm welcome and enjoy their presentation. Thank you.
Good morning. I want to thank you guys for showing up and having me talk a little bit about high friction surface treatments. Again, my name is Matt Johnson with Upper Great Plains Transportation Institute. So today I'll give you a little lowdown on what high friction surface treatments are, and then we'll follow up with a project that was completed in Mountrail County in 2021. At the end, we're not going to have time for Q&A, but if you have any questions, feel free to find me after the presentation and we can discuss high friction surface if you want. So maybe I'll figure out how this goes. There we go. So as I said, we'll do a little introduction on high friction surface and then follow up with Mountrail County project. So what is high friction surface treatments? It's basically a cost-effective solution to a safety improvement. So put down a polish resistant aggregate onto and it's bonded to the pavement with a polymer resin. And the idea is to improve the friction so we can enhance skid resistance and reduce crashes. Yesterday, Justin Slosser talked about HSIP funding, and part of that, their goal is to reduce significant fatalities and crashes. So this is a tool that we can definitely use to improve that skid resistance and that friction surface. So it ties directly to Vision Zero that the DOT talks about so much. So the high friction surface treatment is based upon two products. The aggregate, it's a calcined bauxite, which is heat treated. It has a 3 millimeter nominal max size. And then the resin is a 2-part epoxy that bonds to the pavement, and the life cycle for this type of project is about 7 to 12 years. In Wisconsin, they're seeing a little bit longer life than 12 years. So hopefully that's something that will come true here in North Dakota also. Areas of application, we're looking at horizontal curves that are very sharp, steep slopes at intersections. Intersections could include like a roundabout. Bridge decks was kind of the original area that this was used at. We use it at crosswalks to provide skid resistance at intersections there. And then another application is to do a lane demarcation. So if you have a bike lane, you can color the aggregate different color to denote that lane. Site selection. Basically, we're looking at two ways to approach it. Either by crash data, which is kind of a reactive approach, or we can look at the risk factors. Going back to, how steep is that slope? How sharp is that curve? And if we take those risk factors, we can predict where we need to make an improvement with high friction surface treatment. And in that way, we're looking at a proactive approach. The existing pavement fixture is also a key component. What do we have out there existing and what are we looking to get to? And then the benefit cost analysis. In lots of cases, it's cheaper to do an improvement like a high friction surface treatment than to do a geometric geometric change to your roadway. So once we've selected a site, we've got to make sure we go out and inspect it. Make sure that the pavement's in good condition, because a high friction surface treatment isn't going to repair any of your defaults in your pavement. So if you have poor condition pavement, you need to remove it and replace it before you put down the high friction surface. So application becomes a key component. Obviously in all construction, application is important, but here it's really important to make sure your pavement's dry. Make sure that we've removed all the grease and grime off the roadway. Remove the epoxy pavement markings. And then when we apply it, we want to use an automated system, because that way your resin's going to be laid down at a uniform rate, and your aggregate is going to be uniform. When we use a manual application or hand method, usually on a smaller project like a bridge deck or a radius, but it's better if we have a automated application. You can see here in the picture, this is a truck that was used in Mountrail County. It holds the 2 parts of a resin and then the aggregate in the one truck. So the project performance, parts of the high friction surface that will fail would be delamination, and that would be either by the pavement being wet during application, or if you have a poorly selected resin that doesn't adhere to the pavement properly. So there's different resins out there. We got to make sure we apply the right resin to the application. Oh, and then end of service life. So what do we do with high friction surface at the end of its project life? So 12 years down the road, do we just put another high friction surface treatment on top of it? No, we can't do that. So we either need to remove that high friction surface or cover it up with like an overlay. So durability, that's probably the biggest question that I get. You know, how durable is it? How's it going to stand up to snow plowing? Those sorts of things. And the answer is it holds up very well. So the heavy snow plowing, that sort of movement across that surface doesn't affect it. The calcined bauxite is the best aggregate that we can use. And the reason is it's heat treated at about 3,000 degrees Fahrenheit. And then it has a high alumina content, and the hardness is, it's more durable, more hard than taconite or flint or granite. We have a bulk density of about 3.1 to 3.25, so it's very durable. As far as costs go, the biggest cost is in the polymer resin. That's about 50%, installations 35%, and the aggregate only constitutes about 15% of the cost. So make sure we use the right aggregate. Nation average is about $26 to $35 a square yard. In Mountrail County, it was $37.90. So a little bit higher than the national average, but in the ballpark. So let's talk a little bit about the project that was completed in Mountrail County. It was bid through the DOT. They used HFST funds for the project. So Mountrail County applied and was granted those funds. And safety is the main concern. So that's why the HFST funds were used. And again, it ties back to Division 0 and reducing crashes and fatalities. So the project is located on County Road 21 from Sanish north to North Dakota 23. So it's just east of the Four Bears Bridge at Newtown. Kind of in the very upper left corner, you can see a little bit of the river there. But you can see it's got a curve and it comes to a stop condition at North Dakota 23. Here are just some before and after pictures. On the left, you have the before picture, and on the right, that's after it was completed. But you can see there's a steep grade there and a little bit of a curve. So those were the factors that led Mountrail County into choosing a high friction surface treatment. So the traffic on this roadway was, when it was originally designed, was at 1,520 ADT, and about half of that being trucks. So a lot of oil traffic in this area, a 9% grade, which is pretty steep. It's north facing with a lot of trees, so the sunlight doesn't really help get that icy condition fixed. So there's many accidents, but probably as many near misses. So those were some of the factors also. It was bid February 5th. D'Angelo Brothers out of Hazleton, Pennsylvania was the contractor. We had two other bidders. One was from Arizona, one was from California. So you can see it's kind of a specialized application. Project length was 1,900 feet. And the total cost of the project was $288,110. So the contractor started work August 11th. Took about 4 days to complete. I'd say working days took longer than that. We had some weather delays and we had some equipment breakdown. One thing, the high wind doesn't allow the project or the application to be done, because the wind will affect the resin as it'll displace it. So there's 2 days that the wind was too high to work. And then we held a demonstration project. We went out and took a look at the contractor's work. We had 18 people that took part in the demonstration. And Sabre Engineering was on site during the entire project. So prior to the project, the contractor removed all epoxy paint and symbols, and the roadway was swept. The epoxy was applied at 60 mils, and the aggregate was spread at 16 pounds per square foot, and we had a retention of about 14 pounds. The product does not need to be rolled. It's just the resin's embedded, or the aggregate's embedded in the resin, and we're looking for about a 50% embedment. After it cures out, the roadway is swept, and then we open it back up to traffic. On this project, it was about a 2-hour cure. So this is just a picture of the application. The aluminum sheet in the front is where the resin comes off, and then the aggregate is spread about 2 feet further back. Here's a picture of John Sabre with Sabre Engineering, checking out the application process. The existing surface was had a chip seal completed in 2015, but by 2021 there wasn't much of that chip seal left, and that dynamic friction was 0.42. So after we put the high friction surface treatment down, we had a dynamic friction of 0.97, so a little over twice the friction value. This is the tester that was used to perform those tests. You can see on the right side, there's 3 pads that rotate and determine that friction value. So in the first 3-4 year period, we're going to see friction values stay within 5 to 10% of the original value, and then it starts to drop off. And by the time we get to our 12-year period, we're going to be back to near existing conditions. So this was a picture from December 9th, and the product is working as expected. Here you can see on January 4th, We had a bunch of snow and ice on the roadway. So with the high friction surface, you still need to do traditional snow and ice removal methods. Yana Hennessy, the Mountrail County engineer, says it's not like a heating blanket. You can just plug in and melt the snow and ice, you know, and you still have to go out and do the work. But once you expose that high friction surface again, then you're back and running. So the team that did this work, I want to give a big shout out to Mountrail County. They had the vision to do something new and innovative. You know, first high friction surface in the state of North Dakota. Saber Engineering took on the task of designing this new concept new to us, and then the DOT for helping with the funding on the project. So here's a picture of our demonstration team. If any of you were there, thanks for staying around. It was a long day, but I think worthwhile. So all those people that made this happen, I want to thank them. You know, new innovation starts with innovative thinkers. So we want to say congratulations to Mountrail County. And now I'll turn it over to Josh to talk about auto seals.
Okay, you guys got my presentation coming up? Nope. There it is. So I'm Josh Loegering, the LaMoure County Highway Superintendent, and I've been in that position for 4 years. And I have a really good commission, but they ask me quite often, why do you always have to try new stuff? Because, and you know, I don't try anything new without a purpose. And in this case, with the OTTA Seal, we really needed to find a solution to, we have 160 miles of paved road. Half of those we're never going to have the money to overlay. And these miles, while the pavement structure is still pretty good, the transverse cracks have gotten completely out of hand. They had gone years without crack sealing. So the roads have gotten really rough, and it's not just one crack in these locations anymore. There's maybe 3 to 5 cracks in the same dip. And so it's just gotten way out of hand, and people will completely avoid these roads unless they live on them or farm on them. So we needed to find a solution, and I heard about OTTA Seal 3 years ago at the local roads national TRB conference in Kalispell, and it just was really intriguing. And in a nutshell, what an OTTA Seal is, it's a chip seal where you use a slightly different type of oil, and instead of rock chips, you use aggregate gradation that's basically gravel. We just use the gravel right out of our class 5 pile that we put up. So just a quick overview on what I see as the benefits of an OTTA Seal. It was originally developed in Norway in the 1960s. It was first completed in the OTTA Valley, that's why it's called an OTTA Seal. And what's interesting is the first road they did this on, it's still OTTA Seal to this day. They've done more layers over the top, but it's a very durable surface and it lasts a long time. But one of the big things is whatever kind of material you have in your local pit, you can 99% of the time you can make it work for an OTTA Seal. The gradation is not real specific. They designate a top aggregate size and then no more than 10% fines. And I'll talk about that in a little bit. It's a much cheaper alternative to asphalt on your low volume roadways. So when I'm talking low volume, our high volume roads are like 300 vehicles a day. So anything less than 300, they actually say this will work in anything 500 or less. The roads that we've done this on this last summer were like 150 to 200 vehicles a day. It's actually cheaper than a chip seal. The oil that you use is cheaper, and obviously class 5 gravel is much cheaper than rock chips for chip sealing. A double OTTA Seal, which is what they recommend, has a really good service life, 8 to 15 years, depending on your traffic volumes. So that really intrigued me. And the big thing for us was I wanted something that we could do ourselves at the county. And you use all the same equipment you use for chip sealing. There's nothing special. So this last summer, we did 3 1-mile test strips. The first 2 were on existing asphalt. Now, the OTTA Seal was originally developed to be used on to convert a gravel road to a paved surface. But when I looked into it, Iowa had done quite a bit of auto seal on existing asphalt. And that was my main thing I wanted to solve, was these asphalt roads we were never going to overlay. So the first 2 miles were existing asphalt. The first mile, we didn't do any surface prep. I wanted to see how much a double auto seal would improve the ride, because that was the main problem we had on these miles. The second mile, we did a 1/2 inch to 3/4 inch micro milling to level out all the transverse cracks. And then the third mile was actually part of a 4-mile segment that we reclaimed in 2020 that was asphalt, that we reclaimed to gravel because of the poor asphalt, and with the intent to use prairie dog funds to reconstruct and repave these 4 miles. We're still waiting for the prairie dog funds, and so the people living along this were not happy, because I told them, yep, you're going to get this paved in a year. We're going to have the money, and it's still gravel 2 years later. So I thought this would be a perfect location to do this, because we had good base material, and we could save a lot of money if this worked. So that was the 3rd mile. The project prep is, so this is a pretty thin layer. It's even a double lift is about 1 inch, no more than 1 inch thick. And so you need to fix any subgrade issues. It's not going to bridge over any soft spots or potholes. And then as far as surface prep, if it's a gravel road, you're going to prep it the same way as if you're going to pave it. And so that picture on the bottom left there, that's the gravel segment that we prepped for auto seal. That windrow on the right, if you can see that, that was all the loose material, because you don't want any loose rock that's not, well compacted into the surface. So that was all bladed off, and we used that material after the project to build up our shoulders. And we did find that the auto seal by itself doesn't improve the ride. I figured that was the case, but I wanted to try it anyway. So in the future, we will always be milling before we do an auto seal, if our intent is to improve the ride. So the project process is real simple. It's identical to a chip seal until you get to the rolling. So I'll talk about the oil in a minute, but the whole point for an auto seal to work, the oil that you apply needs to bleed up through all the aggregate, opposite of a chip seal. You don't really want much bleeding on a chip seal. But an auto seal, you really want the oil to flood the aggregate, come to the surface, and really embed into that. So the rock isn't really embedded into the oil. And rolling for 2 or 3 days, we did for 2 or 3 days, really just blends and mixes the aggregate and works all the aggregate around, and it works together. Because you got all different sizes of it's gravel you're putting down. So it all blends together, and you're really kind of mixing asphalt on the road. So another part of that is you want to allow traffic immediately, because the more traffic you have on that when it's fresh, the better kneading action you get with the aggregate and the oil. So we did our first rolling passes, and then we opened it up to traffic. And after 2 to 3 days of rolling, so we used our rubber tire rollers the first day, and the second and third day we used our motor graders with our walk and roll packers to do the compaction. And then any loose aggregate that was left on the road after that, we broomed it off, and then we applied the second layer the same way, and then we fog sealed it just like we would our chip seals. So the oil, so for a chip seal, I'm not real knowledgeable in oil, but I do know a little bit. So for chip seals, you use a rapid set oil that cures really fast. But with an auto seal, you want that oil to be softer longer. So you want to use a medium set oil. So this AE150S, this was the medium set oil that was available from our supplier. It's actually cheaper than like your CRS2P oil. And they recommend it's put down at a rate of 0.45 to 0.56 gallons per square yard. I just picked a number in the middle and did 0.5. And that worked well for us. I think next year we're actually going to increase that to make sure we get more oil bleeding through. It is a little freaky. Like we did the first 200 yards, and I run the top deck of the chip spreader, and I look back and like, holy cow, there's oil all over the place. Like it's coming through. Trucks are picking it up. It was just a mess, I thought. And so I stopped everything, and we reset. We backed the oil rate off to 0.45, and did another like quarter mile. And then when I walked back and looked, I was like, wow, that first 200 yards looks great. Like you could tell that's what you wanted it to look like. So you really need to make sure you have enough oil that it bleeds through the aggregate. And then after the second layer, we did a fog, as I said, exact same rate and oil type as we do on our chip seals. The aggregate, they recommend a max size of 7/8. I don't know, these pictures are kind of hard to see, but so you can see the surface, those larger rocks really stick up, and they did work in more over time, but they do stick up quite a bit. This is not a road you're gonna rollerblade down. Please don't try that. You'll get hurt pretty good. Or even bike. So in the future, we're gonna crush, for aggregate we're using for OTTA Seal, we're gonna crush that down to a 5/8 max size. Just to eliminate those larger rock that are sticking up. And they also say you can use crushed or just screen material. So the first layer on 1 mile, you screen the gravel 7/8 or 7/8 screen and use that, excuse me. But the round rocks did not want to move around much. So we will only be using crushed material in the future. One thing they are pretty strict on with the gradation is no more than 10% fines. If you have too many fines compared to the rest of your aggregate, it takes a lot more oil to bleed through. So that's really why they want to limit the fines to less than 10% of your overall gravel. And then at a rate of 50 pounds per square yard. And this is actually really critical. So when we started this, I didn't think like, whatever, if we put too much down, we'll just broom it off. But when you put too much down, the oil, there's not enough oil to come through everything. And when you broom the loose rock off, the oil hasn't really flooded the existing aggregate, because you're losing oil that's on the loose rock. And you really want to stick to 50 pounds per square yard. Really try to avoid overlaps because they don't turn out. So those are some things we need to do a better job on. So just some lessons that we learned. First thing is I'll show some pictures here when this is done, but I was really happy with how it worked out. Just not knowing how well it would hold up to snow plows and trucks. It looks the same today as it did in August when we did it. And the 1 mile, the gravel section is right along, there's a gravel pit right there. And it got a lot of trucks, like right after we did the project. And I thought for sure this is gonna, I mean, there's only that much, an inch over this gravel. I'm like, there's no way this is gonna hold up. And it didn't do anything. Didn't move, didn't rut. It was pretty amazing, to be honest. But some lessons that we learned was, like I said, crushed only 5/8 max size, minimum of 0.5 gallons per square yard. We're gonna up that to 0.55 next year. If you're doing it on existing asphalt mill before, I talked about this already, less is more when it comes to the aggregate, no overlaps, and you really can't roll it enough. Even like, we only rolled it for 2 or 3 days. We didn't do the second lift for maybe 2 weeks, I think. But even a week and a half later, you could go out there and still move, like with your hands, just move the rock around. Like this oil stays soft for a long time, but the rocks don't come out of it. It's incredibly sticky stuff. So you could even roll it more than 2 or 3 days, and I think you'd end up with a better product. So this is a few pictures. I took these in February, so a couple of weeks ago. So you can see the larger rocks sticking up. So the downside that we've seen so far is there is more road noise. This will be eliminated, I think, with the smaller aggregate. And also the ultimate OTTA Seal is to do a sand seal on top of all this. So we're going to do that next summer. I didn't want to do a sand seal right away, not knowing how it would last. I didn't want to throw more money at something that wasn't going to hold up. But if this holds up over spring, we're going to sand seal it. And I think that'll give us a nice smooth surface. This is a close up. Looks kind of weird on the big screen, but so you can see like right around the quarter is really what you want it to look like. Whereas you see all those larger rock around the outside, that's what I want to eliminate. But even with those rocks sticking up, this road's been plowed, I don't know, 15 times this winter. Them rocks are still there. The plows can't even tear those out. So they're really stuck. Another thing, so these transverse cracks, even after milling, like I said, there's 3 to 5 cracks in each dip. And this is all that shows through. And if you go down to the next, to the next mile that we didn't auto seal, these cracks are 2 or 3 times as wide. So this material definitely stretches more than asphalt. So that's pretty encouraging. This will need to be maintained just like if it was asphalt, you'll still have to crack seal it. But I was really happy to see that these cracks were only this wide. This is the gravel portion. I'm sorry, there's snow on the roads, North Dakota. Like I said, it's really amazing. This is only, like I said, 3/4 to an inch thick. And a lot of trucks right after the project. It was during harvest when we did this, and it just really held up well. I mean, even the fog has hardly come off. I mean, you can see a little bit from the plows, but they've just scrubbed the fog off the bigger rocks. The fog is all still on there. This is the gravel portion again. This is kind of a weird perspective, but you can see how the rocks kind of stick up. And that's really the one thing I really want to fix in the future. Again, this is to the right of the quarter. That's what you want it to look like. And all them larger rocks, I'm trying to get away from that. So that's really all I had. We are planning on doing, if this holds up over the spring, that's the next big test, if it holds up, especially on that gravel portion, if it can handle the thaw cycle. But we're gonna do the other 3 miles of the gravel that was reclaimed back to gravel from asphalt. We're gonna finish that, and we're gonna do 20 miles of, maybe that's too big. I haven't decided yet, but I wanna do 20 miles of it on our worst road for ride. Because everybody, as soon as we did the project, everybody loved it. They're like, it's kind of loud, but it's smooth. There's no bumps anymore. So it was pretty encouraging for me, and it's really inexpensive, and the county we can do it ourselves. So any questions, feel free to contact me anytime. So that's all I got.